What's up, everybody? Welcome back to another YouTube video. My name is John Hammond, and we are taking on the HackTheBox Cyber Apocalypse Capture the Flag and a couple of videos here. So I'm going to dive in to the forensics category now. We've been doing a couple videos, I think, on the web category, but I think it's time we moved on. And let's take a look at this invitation challenge. The challenge info here says, last night I received an invitation, but after I accepted, some weird things happened on my computer. So this does not have a deployable Docker instance, so we'll just go ahead and download the file here. That will bring it into my downloads directory, and I will go ahead and move that into this directory right now. I'll go ahead and unzip this for the forensics investigation. Okay, it looks like it makes an invite file all on its own. I figured that would be another humongous thing like the previous challenges, but let's actually just go ahead and create a directory for that then. We'll call this invitation, and I will move that invite into the invitation folder. Good. Let's hop over there and let's see what we're working with. This is a invite.docm file. So some of you might recognize that .doc extension. That's kind of a file extension typically used for Microsoft Office documents that you would open with Microsoft Word. So when I run that file command and we see that output, hey, this is a Microsoft Word 2007 and up file, that M at the very, very end here typically means that this is macro enabled. Now, macros are those pesky little things that will ask you once you open up a Word document, hey, do you want to enable content on this? So macros will allow that document to do things like programmatically execute code and follow through logic. So malware authors, threat actors, and bad guys might do some spooky, squirrely stuff with macro-enabled Word documents. I think that's what we're going to be diving into here, and I'm pretty excited because I do like a decent amount of quote-unquote malware analysis on my channel where it is looking at some scripting language stuff that bad actors and threat actors might use for elite hacks, right? So let's examine what this file might really be. If we know that it is a docm file or a macro-enabled Word documents, I will end up using a tool OLE VBA, and that will allow me to kind of examine what macros are present in that document without actually opening it up. So I don't want to open like Microsoft Word in whatever public, accessible computer that might be connected to the internet doing strange stuff, because I don't want that to literally be infected with malware or do strange things. So sure, you could run it in a VM inside of a virtual machine, kind of in a constrained network environment. But to play it super duper safe, I'm just going to be working in my Linux virtual machine here, and I will use OLE VBA as a utility to examine it. So OLE VBA with our invite.docm file. Once I hit enter here, it will churn out a lot of stuff. I'll scroll back to the very, very top of this output, although I'm sure there's going to be a lot. Sorry for this seizure here. Let's get to the very top of this code. There we go. It's going to examine this specific file, and it lets us know that there is some code in here. There is Visual Basic, or that VB portion of it. Looks like this code will define functions, or define variables. Dim is that keyword in Visual Basic to do that, specifying each of these as a string. There is a lot of this code here, and scrolling down back to the very, very bottom, after we get through all this, OLE VBA does some interesting stuff. It'll go ahead and try to notice some specific behavior or activities that this malware, or not always malware, sorry, this macro might do. It'll notice, hey, it'll auto-exec code with the auto-open kind of keyword or function call. So right when this document is opened, if you were to click on enable content and allow all of this to execute, it'll just go. It'll just do it. That could be bad if you don't know what it's doing, right? It will do suspicious things like maybe run shell commands or system commands. It will try and obfuscate or hide specific characters, kind of what it's doing, right? And it might even run other PowerShell languages or PowerShell scripts or other system level interpreted languages that could do more dangerous stuff. Like PowerShell's kind of notorious for that, right? At least for the bad actor stuff. It'll also try and detect some hex strings, etc. Let me verify if we could actually write out with OLE VBA what we're going to end up doing, or save these files here. So I'm going to just check the help with TAC H. you could pass in some zip file and the passwords in here or anything, or we could just get code, right? Display only the source code and do not analyze it. And I wonder if we could actually have this write anywhere without redirecting it. Output mode. No. I guess we can just redirect it and kind of cut stuff up. So let's try that. Let's use that OLE VBA one more time and redirect that out to, I guess, output.text. Okay? Now we're going to have a lot, but we can carve out some of this stuff. I do see some VBA macros being defined. So I'm going to specifically look for this delineator, or like what's being used here to determine one macro versus the other. So there's the guy, this big pile of code. I'll go ahead and save that as, I guess, top.vb, or for Visual Basic, or Visual Basic Script, VBS in that case. And then let's grab this other one down here, and that will go until it goes to analyze specific parts. So let's bring that to this position, actually. There we go. I'll call that, I guess, bottom.vbs. So let's start with the top one. One thing that I like to do is kind of let malware or bad code, if it's obfuscated and doing really weird stuff to kind of hide itself, I tend to like letting that do and like unravel itself, obfuscate it on its own. We could do that. We could kind of mess around. But let's figure out what these functions are and what they're doing. It keeps calling this ODUSUOZLDXFU, whatever that thing is. We need to go figure out how that's defined. I can see it down below here. We do have a private function set up with that file or that function name. I'll indent this so it's a little bit easier to read. Looks like it's starting a for loop. And this takes in some argument. So we'll call that, I guess, argument 1. And we have an iterator, seemingly, because this for loop will count from 1 to the length of the argument supplied, stepping by 2. So I'll say that variable can be an iterator. I'm just using a find and replace within Sublime Text, or Control-H in my case. Control-Alt-H, I believe? No, Control-H and then Control-Enter to replace all. So in Visual Basic Script, a function return value is actually just going to end up implicitly returning based off of the name of the function itself. So it looks like it's going to try and put together a string. Adding it all together, this ampersand will concatenate or append values in a string in Visual Basic Script. The character representation of the value determined with hex representation of the middle of a string or a substring from the argument at the iterator offset, adding 2 onto it. So basically, it's going to take all of these values that are passed in, as we see this function called, and get the hexadecimal value, but decode it. Decode that hex value. Read that as if it were hex. So this function can just very easily be called decode hex. Nice. Looks like we do a lot of stuff here, and we keep adding a bunch of things, but these are all portions of one big long variable, again concatenating things over and over and over again. So this could be something that we could kind of cut up and work with. We'll call this, I guess, part 1. Good enough. This other one that we see defined here, that's going to be part 2. Next one, of course, is part 3. Oh. And just above that, we have part 4. Easy peasy. So it puts all this together and does something with it. But we need to know what all this code is as like decoded hex. So let's try and recreate this thing in Python, which I know sounds crazy, but it'll work well for us. I'm going to go ahead and use like a first.py, and I will paste all that code in. I am going to import Binaski so we can decode hex pretty easily in Python. And Sublime is going to run sublac and totally nerf all that. So let me toggle that off. There we go. Now everything that calls decode hex, we can go ahead and just replace that with the bin ASCII unhexlify function. So then we end up decoding it. Now, Visual Basic Script was using an ampersand to concatenate things, but we'll need to go ahead and use a plus sign because we're in Python at this point. This underscore was supposed to represent, hey, continuing on to a new line. In Python, that is a backslash. So at that point, part 1 will eventually be evaluated out to all these different portions. Same thing with part 2, part 3, part 4. Now, X is going to be set to a shell representation, probably trying to run whatever is present after we decode all this. But that's not something that we can do in Python. Let's actually just print and display that out. So I will use print rather than shell here. And it has a 1 noting at the very, very end. That 1 is just going to be like how it will execute that shell function back in the Visual Basic Script style. We won't use that. We'll just go ahead and, display this all out with Python. Since it's set to a variable, I don't want to do that. I just want to display all this content. So let's see what happens with that first .py. Looks like we get a ton of base64 data, and this is seemingly encoded PowerShell. So I'll call that in its own file, I guess, stage 1 first .ps1, I think is fair to say. You can see it's running PowerShell with all of that, but it is encoded. It is base64 encoded. So we want to go ahead and decode that. Now, PowerShell encodes and decodes base64 with UTF-16 rather than UTF-8. Now, we're kind of used to UTF-8, but let's try and find a PowerShell decode base64 online or so. Maybe this will behave for us. We can try this tool. Let's decode it, see if it actually determines some stuff here. Looks like it does. So let's grab that and call that stage 2 first.ps1. Now we can see the real code that PowerShell would have ran. There's some stuff going on here. In fact, the very, very top, this is going to end up trying to execute more code with IEX, or a PowerShell alias to invoke expression. Now that's bad because we, again, don't want that code to do things that we don't want it to do. So I'm actually just going to nerf that out. I don't want that to actually execute. But because this is all PowerShell, which is interpreted and executed and sort of a scripting language, like we can play with it, then that's going to be super handy for us because we can just kind of take pieces of this and understand what happens when it runs with PowerShell. We have another base64 payload defined up here. We can try and decode that just to see what the value is. I'll decode this thing. This will bundle up. I'll set that syntax to PowerShell here, and I'll replace every semicolon with a semicolon new line so we can kind of see what this is doing just a bit more. It actually calls out to an IP address on port 4444, right? So that definitely looks kind of sketchy, and it looks like it's actually going to end up presenting a PowerShell prompt. So is this some weird reverse shell gimmick here? We're not 1,000% positive. We don't need to be too concerned with this because we want to know where the flag is, right? We're doing this for the sake of a capture the flag challenge, so we can keep hunting in the rest of that code. But maybe this is something to keep in the back of our mind. If anything, at the very least, it showcases some legitimate techniques used by malware or badness. So there's some learning value in that. Looks like it will even do persistent stuff, like trying to add into registry. Yep. Literally installing itself into the registry. I see that a lot in other videos that I showcase. That's doing that, man. Setting up scheduled tasks for persistence. Running PowerShell with this itself. Literally adding its persistence as the Windows update. Haha, sure. And it pulls itself down from the registry. It does IEX or invoke everything based out of this base64 payload, which is what we've just carved out here. But we haven't exactly de-obfuscated what's gone on at the very, very top of this. So this looks pretty messy. It's using regular expressions and kind of replacing, doing some weird things. So I'll just let PowerShell evaluate this out on its own, and we can kind of see what it's doing. I will open up my command prompt or my terminal here, and I'll just run PowerShell from within Linux. There we go. Now when I paste all this in, looks like this is what ends up coming out, which looks a little bit still obfuscated. It does end up piping and passing into another shell ID call. And this shell ID is one tactic and technique to run IEX. You can see this variable shell ID at the index 1 will evaluate out to an I. Shell ID index 13 will evaluate it to an E. And you concatenate an X. And again, it will invoke expression and do bad stuff. So we don't want to run that, but we do want to see kind of this obfuscated code. What is this going to end up doing? This actually churns out a portion of our flag with regp CHTB maldocs R. That might be worthwhile. Let's actually save that as, I guess, like a notes.md file. But that's only half the flag. So what else is going on? We didn't check out this line just yet. That might do some strange things. But at the very end, hey, we see that IEX. We don't want that to actually execute. So let's take everything before it. It is going to end up setting some variables, it looks like. So let's just, again, try this in PowerShell and maybe make sense of what's happening. Let's see. ls. Part of me wonders if that's supposed to be a PowerShell actual command. Or... Normally that would be something that is case sensitive or case insensitive in PowerShell. It does end up defining variables though. Just to break the fourth wall, let's go ahead and actually open up our VirtualBox and get a Windows 10 virtual machine cruising and ready for us. While that's starting up, we can go take a look at that other macro and see if it's any different, or if OLVBA just kind of churned it out twice, or if it saw a similar fragment to it. Part of me thinks that we are going to get something worthwhile out of this. In fact, I see maybe characters that need to be reorganized or something. Let's try to see if it actually did define these as variables who are used set. Variable is normally a PowerShell drive. So if I try and ls this, let's try and get child item maybe. Let's do that for that variable drive in PowerShell. Okay, so I do see some variables kind of being set up and put together. Is there anything new or out of place in here? There's this G8H variable that's seemingly new. And that would be something that we might want to actually check out, because it looked like our code was going to end up setting a G8H and kind of refer to it over and over again. Let's take a gander at what that might be. G8H, right? Let's retrieve the value out of that. Here's this. This looks like something that will probably need to be reversed. So I'm actually just going to pivot and use Python to do that. I will get this as a double quoted string. And let's reverse that. There we go. So this uses another IEX tactic where we're getting verbose preference to string, indexing an IE, and then having an X in there. So that will, go ahead and run IEX yet again with arguments passed in. So let's have PowerShell determine out what this might be. So I'll hop back into PowerShell and I'll just let this code kind of evaluate itself. Looks like we have the very end of that flag there. So that brings us to these pieces. We have CHTB, maldocs are the new meta. And that is our flag. So that just took a little bit of kind of piecing and puzzling out fragments of PowerShell. I tend to like that technique where you can let PowerShell or let the obfuscated language de-obfuscate itself. You just have to be super duper careful for those function calls that are going to end up being like exec or execute or eval or IEX and invoke expression, specifically in PowerShell. So if it were to be doing malicious things like the fragment of code that we saw that will like literally go ahead and maybe have a callback or reverse shell, this actually does other interesting things like being able to import and import is not the right word, but compile and load in the power of C# kind of on the fly. Add type is a commandlet that will literally take in C# syntax and then compile it so that you can use like that managed code inside of PowerShell. Crazy, right? We specified a window class from a namespace, and then we would be able to actually call stuff from it like show window or get console window that we've actually pulled in from other DLLs. So we can run Win32 API calls. That can get kind of dangerous if you're doing stuff like allocating memory and copying shellcode into memory and executing that shellcode, right? All within PowerShell. So I think this was a super cool challenge, if just to get a little bit of familiarity with some stuff, really crazy, spooky things you can do with malware, especially, I mean, even PowerShell, right? Just in its case, all pulled from doing things out of Visual Basic Script when it is obfuscated like this. So I didn't end up driving down that bottom.vbs, but truthfully, this looks pretty similar to, I think, what we originally had as our top VBS. So yeah, this looks pretty much identical from what it was. Maybe it's just OLE VBA showing that to us twice. I will wait for you to scream at me and correct me in the comments, and you can let me know. Looks like we didn't even need that Windows OS or virtual machine after all, because we were able to piece it together knowing that LS call, or that L capital S, is just going to end up like getting the contents or the child items, all the entries in a specific folder. And PowerShell drives can allow us to do some introspection on variables, or even variables that are set within the context of this PowerShell session. That's how we were able to drill down on that G8H variable and make sense of it there. All right, it's enough of me yapping. That was a lot of talk, but I hope that was something cool. I hope that was something fun. And thanks so much for watching, everybody. Thanks for letting me nerd out for a little bit with something that feels kind of close to home, right? With other videos that I do, not strictly capture the flag, but also some malware analysis with kind of languages like this one in PowerShell and Visual Basic Script. There's a lot of good nuggets there, and I think it's very cool to showcase. Awesome for HackTheBox for putting something like this in their CTF. That's it. That's all. I need a drink of water, man. I've been talking for a while. Hey, thanks so much for watching. Please do those YouTube algorithm things. I would love if you could like the video, comment, subscribe, hit the bell. I'm super duper grateful. Thank you again and again. I'll see you guys in the next video. I love you. Take care.